Okay, so we are going to the next level of our learning. Yesterday we were going through the select statement, everything. Today we are going through the understanding the count, distinct, or limit kind of things. And let's go ahead. And so the agenda of today is the introduction to SQL expression, understanding count function, practical example of count, understanding distinct function, and a practical example of distinct function, limit, understanding the limit function, and all the practical examples of limit, and combining count, distinct, and limit together, common use cases for count, distinct, and limit, and best practices in using SQL functions. Okay, so let's go ahead. And so in the foundation of SQL and data management, so the it's already like we have gone through the overview of SQL, structured query language, yesterday, and let's go ahead. So the definition of count, the count function in SQL is an aggregation function that qualifies or quantifies the number of rows in a result set. So it can be applied to all rows or a filtered subset to yield the meaningful counts and critical for data analysis. Okay. So in actual queries, the usage of count is that users to understand the volume of data entries, like such as that I have a table, but I don't know how many records are there. Let's say I want to check the sales table, the customer records. So I can check that how many records are available in my tables using the count function. It's an aggregation. It will return you the number of records. So, for example, counting rows in a table, a practical example involves select count star from the employees. It will give you the number of employees to determine the total number of employees records available, showcasing how aggregates inform organization insight. So, practical example working with, we'll work on the tables also. So, creating a me tables, like we are going to create a table querying total rows of the table, and then inserting results, interpreting the results. So the output of the count function reveals the total recorded instances. Okay, so understanding distinct function now. So retrieving unique entries in SQL, like whenever you want to retrieve the unique data from the record, then you need to use the unique or distinct functions. So the distinct function keyword in SQL filters out duplicate records from query results. Okay, returning only unique values, and the distinct function essential for ensuring data integrity and clarity in dataset involving repeated entries. Okay, so the purpose in SQL queries, like what the purpose is that we only need, if you are having the lots of records in the table, and for example, let's say I have a customer name, and with the same customer there are many customers. So I want to find out that, like, how many unique name of customers do I have. Then you can use the distinct keywords. Okay, so in the example, like retrieving unique values, for instance, running select distinct country from middles, like there is a, let's say, a country table you have, then you can run a distinct country from middles, something like that we can do it. Okay, so we'll go to the we'll go to the SQL. We'll check the SQLs also. Okay. So understanding limit function, controlling SQL query results. So definition of limit, like the limit clause in SQL restrict the number of rows written in a query result set. So allowing the manageable data retrieval, especially in large data sets where only a subset may be required. So when you have like thousands of records, or like millions of records, you don't need, you cannot interpret all those records. So what will you do? You will just limit the records, how many records you want to fetch. At least you can do some data analysis on that, on that data. Okay, so purpose in SQL queries, limit helps improve performance by minimizing data load, ensuring that only relevant rows are processed, especially when working with the extensive data sets, okay, during the exploratory data analysis. Okay, so we will check the example also. Okay, So combining count, distinct, and limit, like maximizing SQL utility. So like this is like we want to write a proper query, perform a better optimized query with the limited records. Then we can use the combination of count, distinct, and limit. Using functions together by intersection, count, distinct, and limit in a single query, users can derive comprehensive view of data patterns and values, thus enriching our analysis. Okay. So, what is the benefit of combining functions? They create the form of the functions, maximizes our analytical potential, allowing for deep dives into the unique data endpoints while managing load and complexity. Okay. So the common use cases for count and distinct, like anyone can ask any kind of questions, but if you know the use case of it, then you can apply it anywhere. Okay. So employee count, distinct, and limit in data analysis enables analysis to produce clear, insightful. All this like data analysis reporting and performance optimization, avoiding common pitfalls, optimizing queries, and ensuring data integrity. Though all these kind of things we can use it. Okay. Okay. Now coming to the understanding the insert statement in relational databases. Okay. So how you write the insert statement, and we'll do the practical also. But how you write the insert statement in the relational database, how you design the database, and how you write the queries, everything that we need to understand. So introduction to insert statement, understanding relational databases, and syntax of the insert statement, adding single rows to a table, inserting multiple rows, common errors in insert statement, best practices for using insert, practical application for insert statement, and advanced insert techniques like how you can upload the .SQL files and case studies you can check, and then like this is what we are going to learn. So what actually we are going to do in this particular part of the section is focus on the insert statement. Whenever you, let's say you have a table, you did not insert any row, you can write an insert statement and then you can insert the data. Okay. So purpose of the insert statement serves as a fundamental mechanism for adding new records to a database table, enabling data expansion and the growth of the relational data sets. Importance of in relational databases, insert operations are critical for populating relational databases, allowing them to maintain up-to-date information that reflects real-world changes and user interactions. Okay, so understanding the relational databases. Okay, so defining structures and roles. So definition of relational databases, like relational database organize data into structured formats comprising rows and columns that facilitate data retrieval and manipulation through defined relationship. Okay, structure of the tables. Table consists of rows, records, and columns fields where each row represents a unique entry and each column corresponds to a specific attribute of the data. Okay, so I think we should go to the, yeah, let's go through the PPTs, then we'll go to the practical approach. Okay, so the role of data, like there are like DDL, data definition language, there are DML, data manipulation language, there are DCL, data control language. All these kind of things we can see it. Okay, so role of data manipulation language DML is that like a structure of tables that when you define it, that is comes in the DDL, data definition language. Okay, definition of relational databases. Let's say you want to design a database and you want to create a data tables in that, then you are going to uh, define the table, create the define the architecture of the table, create the tables, then insert the tables. Then so the basic syntax of the insert statement, like the simplest insert syntax follows the forms insert into table name and column 1 and column 2 and values value 1 and value 2. This is the basic syntax that you can use. Okay, there might be complex syntax also, like if you have so many columns, then there would be another way to insert it, and like it's not another way, but sometimes let's say you have date value, then you are going to use some date function to insert the values. So the basic syntax is, so you are not directly going to insert it. If let's say a table doesn't exist and you are going to insert it, it will give you the error the table doesn't exist. Okay, so components, table name, columns, and values. Key components include the target table names, the specified columns to be filled, and the corresponding values being inserted, which must align correctly for successful execution. So, whenever you are defining the database, when you are creating the tables, you need to properly define the syntax, provide the data type, the length of the data type, whether you are providing the architecture or whether you are providing the foreign key constraints, primary key constraints, all these kind of things you need to take care. Okay, so that is the that what we are going to learn today. Little bit we'll create a new database, e-commerce database, and we'll try to insert the we'll try to create the database. We'll do the normalization, we'll do some key reference, foreign key, primary key, and then we'll try to today we'll decide the basic architecture, and then we'll go ahead and insert the data, and we'll so example of a simple statement is like this. Okay, so adding single rows to a table, you can add a single row, method for inserting one row, and importance of matching columns. Okay, so inserting a single row involves explicitly stating the table, the target columns, and the corresponding values to ensure accurate data entry. Okay, so an example could be the insert into employees, and employee has a name and values role chunk, which may clearly adds a role as a new data in the table. Okay. Importance of matching columns and values. It is vital to ensure that the values being inserted correctly correspond to the declared columns to prevent data inconsistency and errors. Okay. If you are trying to insert random data in the table, then you are going to face a lots of problem. It is not easy to work like that. Okay, inserting multiple rows, efficient data entry techniques, because let's say you have a big database. Okay, you are not going to work always as a one record to record. Let's say I am working as a data engineer. I have a database exported from my local system, and I want to take it to the AWS or Microsoft Azure or some other data warehouse. Will I able to write the data one by one? Will I able to insert it? No. Then I want to export the SQL file. I want to import that data into other data source. So that all these kind of utilities, you must know that how to export the data, how to create the data, how to design the architecture, how to create the database, tables, because there is a sequence like I need to create a database, I need to create all the tables. Once the table is created, I need to insert or create all the referential integrity constraints, and then I want to also create all the data. I want to insert all the data. Once my metadata is defined, once my structure is defined, once my utility proper integration is defined. Okay, integrity constraints are like it is a relational database. That's why like when you fetch one record, the another record is going to be fetched automatically. Okay, so common errors in insert statement is mismatch column and value counts. Okay. Sometimes what you are doing is like, let's say you have three columns and you are trying to insert four values. Data type mismatch. Another error arises when the data types of the provided values do not align with those defined in the database schema, which can cause runtime errors. Handling null values. Errors can stem from improper handling of null values. Understanding when or where nulls are permissible is critical for success. So, null values, what happens like I define a table. Let's say the table name is customer. Can a customer name be empty? No. First name no, cannot be empty. Last name cannot be empty. First customer mobile number cannot be empty. But I'm putting address, but I am not putting the first name and last name or the contact number. It will not allow me to insert the data in the table, because I already put the constraint on my table that you cannot insert the null values in my table. Okay. So best practice for using insert statement that ensure data integrity. Okay. Maintaining data integrity involves implementing constraints and validations that ensure that the data being inserted and it complements or it comply with the structure of the tables using transactions. Okay. The second point is that employing transaction can help maintain consistency. If multiple inserts fail, the transaction can be rolled back to avoid partial data entry. Okay. Validating data before insertion. Prior to insertion, scrutinizing the data for accuracy and completeness can significantly reduce your error. So before going to insert, before you are going to write the input script or insertion script, you must be validating everything. Okay, so when you are going to be a data engineer, these basic buildings are a key the key things that you need to keep in mind, that how I'm going to design the database, how I'm going to create the tables, what constants I am going to put on the tables, and at the time of insertion, if I am not inserting the columns and rows properly, then I would not able to run the data. So use cases in the real world application is like applications often use insert statements for user registrations, order entries, and other operations requiring new data submission. Okay. Integration with other SQL commands like the insert statement is typically used in conjunction with the commands like select and update, allowing for dynamic data manipulation. Impact on database performance. Optimal use of insert statement can significantly impact the overall performance of the database. Interactions influencing transaction speed and efficiency. So let's say if you did not properly insert the data, you are trying to retrieve the data, you will face the problem, because ultimately always you are not writing the code and you are not interacting with the code editor. Sometimes let's say you build a system and you are interacting your system through the code, then your code would be dying or it will be not executing because your data is not in a consistent state, your data is not good. So you are sometimes you are getting null pointer exception, you are getting other kind of problems. So ultimately your system performance is degrading because the quality of the data is not good in the system. So that's why before inserting in the database, we are make sure that we are going to insert a good quality of data so that our system doesn't suffer from the performance. It does not cause us the slowness of the system. All kind of those kind of things that we need to keep into consideration. Okay. So advanced insert techniques like using insert with select statement. Like if you have one table and you want to create or insert the data from the another table, then you just insert into and select star from the other table, insert with subqueries and bulk insertion and performance consideration. Okay. So we'll go to later understanding the update and delete statement in relational databases, but I would like to go to the we'll go to the database and we'll create a new database. We'll define the new tables and then we'll try to do something. Okay. So here we created e-commerce database. So you see here e-commerce database yesterday I created. Okay. If I say here, it's very easy. Okay. E-commerce. Okay. Create the database name e-commerce, use e-commerce. So what we are doing here, we I want to use this database. Okay. Okay. So I want to write a use e-commerce. Okay. Now I am what I want to see, that I want to check how many tables. So tables. Okay. There is no table in this database. Now, I just want to take one example from the wschool.com and I want to say that I want to create a database from here itself so that like everyone can create the database from here. Okay. So I say select star, select star. So let me do this. Give me 1 minute, huh? I'm just doing for your sake, so you can do by yourself, and I want to see the results tomorrow, what we are trying to do here. What we are doing, this is the schema design. Okay. So this is the schema design that we are trying to do. Okay. So if you say here,
Spelling is wrong for describe.
what is the spelling?
TRIB. RI.
Is it correct?
No, no, RI. RI.
Describe? Is it correct now?
EE. After BE.
Because I don't think it will take the other things. It is only expecting this. Okay, no issue. So this is, let me just give him the data. Just give me 1 minute. Okay, so we are having the customer ID, customer name, address, and city post, and this, and the categories. Okay. So what we are doing here is that we are designing the database schema. Okay. So let's say you have a customer table. I want to design the proper data because we are going to insert these records there. So just give me 1 minute. Okay. So we are creating the table, create data, create table, customer. We are going to create. Where we are going to create? Now we are going to create this in our database. Okay. So we are going to create the table, and we are going to commit it. Okay. Now if you check show tables, then it will show you one customer table. Okay. Okay. So I want to have another SQL because I will create a insertion queries for this. Okay, commit, and then I will copy from here. I will ask you to guys to do by yourself till you learn the things properly. Okay. Mhm. And let me copy the data now. So
Hello, Rajesh.
yeah,
So I have a small doubt. What is the meaning of select star? The star. What is star? It's mean like select all from the customer or something.
Yeah, I'll explain you. Just give me 1 minute.
Sure,
Let me insert the data, then I'll insert. All right.
sure.
Vinas, I need big system, I think, man. Like my system. Just give me 1 minute, then I'll. Okay. So this is our complete insert statement we created. All the 91 records we are going to insert. Okay. So what could be the problem? Let's say, like I just want to explain that we created customer ID, customer name, contact name, address, city, post call, and country. Okay. But let's say if you say here you give the pin code also. So you just give any other uh, value. So now the number of columns is more than number of columns we define in the table. There is no pin code column in my table. So the problem it is going to create. Or sometimes what you can do is like someone can create a new entry here and write something XYZ. Okay. Because the number of column is less than number of rows, the number of insertion, then it will create a problem. So we should avoid such kind of mistakes. Okay. So let's insert our record now and let's see. Okay.
Right.
So
So I have a doubt actually. This is the
yeah,
only way to insert the data. No?
no, it is not only the way this script can like you can write the uh, you can what you can do is like let's say I'm showing you the another way that let's say now I'm going to save this
in Excel or something?
Yeah.
Okay.
Here, customer.sql. The customer.sql. Okay. Now, what will you do? You just need to go and just run it. You don't need to check into the content. But since this is one way, okay. Once the database is completely prepared, then we'll show you other things also. Okay.
Okay.
So now we have customer table here. Now who asked me the question? Someone asked me the question. What was the question? Select star
Star, I
from
think. Yeah.
customer. So what it is doing? What? Okay. So why customer? Okay. Select. Let's select star from customers. Okay. So what it is doing, it will give you all the column. Whatever the column in that table you have, it will give you all the columns. Okay. Okay. If you say, I only need customer name and city, then you will get customer name and city. Okay. If you say that I want to count the number of rows in the table, then select count star from, so 91 rows there. I don't know. If I am working on any database, it is first time, I don't know how many records are there. So I am going to create the records. Okay, I want to check the records. Now I want to check how I want to select the country here. Country. Select star from customer country. Okay. You see Germany, Mexico, UK, Sweden, Germany. The country is repeating always. But I want to check the only distinct countries. Distinct countries. Country. Then it will not repeat. If Germany is Germany, you can write here order by ascending. Order by country ascending. So at ascending it will automatically take. So what will it will take the alphabetically. Okay? It will take alphabetically. Getting? So this is distinct we learn. Now I say I have select star from customers. How many records? I have 91 records, but I don't need 91 records. I need only top 5. Then you can write top 5. I think top, it will not work. Limit, limit 10. Then it will give you the 10 records. Limit 1. It will give you the 1 record. Okay. So we have seen how to create a table, how to insert the data in the table, how to query the data in the table, and we are going to create one more table. Okay, so we are going to create a one more table called orders. So before that, before we create the order, we need a employee table and shipper ID. So let's create the table, other tables first, because we need a, you see here, you see here, order table has a foreign key reference. It means that you cannot add an employee ID. Let's go and run this query in the SQL table. Okay. So I want to run the SQL table. I want to create a table. It will give me the error now. What the error is? So that column employee ID cannot be null needed in a foreign key constant order IB. Okay. In the employee ID itself, it is creating. You don't have customer ID. You don't have, you have a customer ID because you already create a customer table. Okay. And you are creating here a primary key, auto incrementing. Okay. This is my order table. Keep in mind of order table. Okay. Now I want to create another table, that is what I'm using, employee ID. So I need to first create my employee table. Employee table. So I want to create my employee table. This is a very basic database, but first you need to work in this, then I will give you the big database to design. Okay. So if you see in the employee table, employee.sql, if you see it, then employee ID is a primary key. We are defining last name, first name, birth date, photo, and net or text. We are defining the data type. We are defining the how many data length. Not null, it means that you cannot insert the null values in any of these. But photo or notes can be null because we are not defining the not null constraint here. Okay. So if you run this query, then your table is going to created. Why? Because you don't have any foreign key reference in that table, but still customer ID and employee ID, if you try to run this query, you will won't be able to create it. What it's saying, that again it is giving me the customer ID not null, employee ID, but the problem is with the shipper ID. I still did not create it. Okay. So here I'm going and check that how many tables I created in the commerce table. I created two tables, customers and employees. Now I want to create another table. Let's say let's first insert the data for employees. My system is going very slow. So let's insert the data now. For the employees table. Okay. So when you run this SQL script, you will simply, okay, data is inserted. Select star from employees. You see here the data is inserted. Now we need to still create one more table, that is shippers. Okay. So shipper or supplier, what was that? Supplier, I think. In the what we have in that table, order tables, we have supplier ID. So shippers or suppliers. So now let's create the supplier record. Does anyone have any query? This is basic thing, but you need to know properly from the beginning. Otherwise, you'll get a problem. Because the learning should be from zero to increasing order. Okay. So new table is, now new query is your supplier. Okay. Supplier, you have primary key. Only the supplier name is not null. So you should go through the table definition, the DDL, data definition language. This is the data model that we are designing. So what we are doing is, this is the data model design is happening. Okay. In the terms of tech, in the terms of data engineering. So suppliers table we are going to create. Okay. This is supplier table. Okay. Now let's create it, tab the table. The table is created and let's insert the data. Let's insert the data. So this is what, like whenever you are going to work in a project, first of all, you are going to understand the requirement and then you are going to properly understand it and then going to design the database. Okay. Let's insert the database for suppliers. Okay. Data is inserted, commit, select star from supplier. So you got the data and the values from the suppliers. Now see your table, now order table is going to be created because you have customer ID, employee ID and shipper ID. Okay. So let's go and create this table. What man? Set null. What? Order date not null. Shipper ID int not null. Employee ID, customer ID int not null. Copy row. Oh, what the issue? So what you're saying, the column error employee ID cannot be null needed in a foreign key constraints. And orders FS set null occurs because in foreign key constraint you specify on delete set null. On delete set null. Where did I specify that? On delete set null. Cascade. Set null. On delete set null. So I think okay. Put cascade for all foreign keys. So another term we are using that when a record is parent, when a parent key is deleted, the child record must be also deleted. Okay. So let's go to the table again and let me I cascade. Reference scheme, foreign key, personal reference key on delete cascade. On cascade. Working. To open the reference table shippers. Sweepers we already created, no? यार किसका रेफरेंस ले रहे हैं? शिपर आईडी और सप्लायर्स को सप्लायर शिट. I did not create the ship or supply. I created the supplier but not the shipper. So by mistakenly we created another table. Are you guys with me?
Yes, sir. Yes, sir.
Okay. So we created and United package shipper ID and have the database. I think ChatGPT already. Let's create the insert the data and commit and then let's go to orders and create it. Okay, now let's insert the data of orders. So I would request everyone to do the same exercise in your database. Okay? It's open door, so it is a good practice to learn the things, basic things. You can do it. Is there anyone who cannot do it? Yeah. Mahendra, Vikrant, is there anything that you don't understand?
No, bro. I think we can do it.
All good.
Avinash, Vikrant,
I'm good. I'm good.
Yes, sir.
are you able to do it?
Yes, sir.
If you don't able to do it, then let me know, okay?
All right. All right.
But try to do it by yourself tomorrow. I want to check live. Okay?
Okay.
This is basic stuff, but do it by yourself. That's what I'm just trying to, because when you do it, you will learn by yourself. Okay?
Yes.
Vikram, do you have this uh, MySQL installed? Do you know how to install it? How to
Yes,
work on that?
I have on my laptop.
Okay.
Yes.
So please try to do that. Okay. Everyone know how to create a database and create the tables and everything. Okay. Now you got the like that. This is the way we create the database and we add the tables and everything. But you know how to, the best part of is that how to create a consistent and normalized database. That is the approach that we are doing here. Okay. So this is what we have here. We have already 4 tables in our database: customers, employees, orders, shippers, and this. And let me export this database. Commerce. Okay. Okay, my database is exported. Now I want to go in the table in my documents, and I want to check in the dumps that what is the date today? 18/20, this one. Okay, it is then at. So if you open these now, my system is really going to die. I don't know. It will not create, should not create a problem. Okay. What? It's showing that it doesn't exist. 22 KBs. What is 218? That is the today's date now. Just we exported. You see here, this is completely what is the database name, what the table, the data, the table, data, table data. Okay, everything is there now. Okay. So I can send this, but what I'm saying is you try to do by yourself. Do you want me to send these, or you will do it by yourself?